You close the door there, Pogba. Yeah, you are? That's cool. There's still people coming in. Oh, I need more chairs. We are sold out tonight.
Yeah, you've got a popular topic.
Yeah, yeah. You better deliver. Well, I'm just a warm-up. Full of me. All right, we'll get started. Very welcome to this session about integration with CET Designer. I will be presenting about half of it, and I will do an overview over different ways to integrate with CET. And then James Redden from Knoll will talk about a specific DLL integration that he and well, you and your team has been implementing. So it'll be good. My name is Staffan. I've been with Configura for 20 years, and well, it's a long time. If you got any questions during the presentation, feel free to ask. We'll try to answer. So, integration is of course the business of connecting CT to other systems. It can be well, it can be anything that you like, I guess, but you need to have some kind of protocol to access them. A few examples I thought about is like interacting with a part system or a CRM system or a production system. Also, if you do file transfers, since CM is a non-threaded language, then all operations you want to do asynchronously, that is really heavy. You need to put in another process, and that's that will become an integration then, because there will be some external thing doing it. So one thing to categorize, I think, is the integration local or remote. Local would be, calling or making direct calls to a DLL, or have some kind of inter-process communication with another process on this computer. And remote will be everything else. And I'm going to focus more on the local communications today. But I'll mention or go a little bit into the remote as well. And integrations can be very, very simple or pretty complex. So, I mean, the most simple one I can think of is like uploading a file to a server somewhere and hope that that server will do something with it, and that's a fully working solution maybe if you have something that's not critical for your system. And you can go all the way up to full duplex communication where you have handshakes and security checks and everything like that. So it can be really, well, it's a broad span. So to the overview of different ways to interact. And these are the ones that I am aware about and that we support directly or indirectly within CM. So you got the DLL import, you got interop, async CMD, CMQ, and then you got a few database interfaces. You got remote side web service, different ways to access them. Cloud Sync is an upload tool, and HTTP and FTP. I'm going to mention those really briefly. So for the DLL import, which James is going to talk about later, I would say it is the fastest one you can do, because you will get direct calls to I mean, you run the code in the same memory as the CT designer process. So it's basically like calling CM functions or built-in C++ functions. Of course, the risk about running this in the same memory as CET Designer is that you need to be very careful with your memory management, because if you leak in your DLL, it will leak the CET Designer memory, and we expect CET Designer to be run on for many hours, perhaps on some clients, so it needs to be, tight. Also, memory management, as you know, if you don't do it correctly, it will be very nasty to you. Memory errors are like the worst to debug, and if you trash some memory, something else will break somewhere else in the system, and you don't. The crash will have nothing to do with where the actual error was. So you should avoid that. You should make sure you avoid that. So I'm moving on to interop now. I don't know if you're aware of it or have used it at any time, but it's, compared to DLL, for the DLL, you'll probably need to build your own DLL, and you have to make a wrapping layer both in the DLL and in CM. You'll do wrapping functions that sort of match, so you can call the functions in your DLL. With interop, you can set this up all in CM code. There's no need for DLLs or anything like that. So it's very simple that way. You can access, I'm not sure actually how much you can access, but you can at least access everything that is in the .NET framework. And .NET 4.0, I think, has been shipped with Windows since at least 10 years or something, so you can be pretty sure. Okay, this is an example, short code, just creating a net object. So it's creating an instance of this regular expression regex component, which is in the framework, I believe. And then it calls some function there, which is a regex replacement. And this is the whole code to make that call into an external system. You don't need anything else. I'm going to look a little bit into another example, just to show you. If you have need for a certain function, in this case I took the MD5 hash as an example. If you want the sort of Microsoft compatible version of it or whatever, you can find it in Microsoft Docs somewhere, and you can find where the component is there for the MD5, and it's also the hash algorithm, compute hash method that you need to call here. So you can find the information about this, and here is an example of doing that. And this is all the code in this case too. It's a little bit more complicated because it's creating a MD5 object first, and then it opens a file, which we cannot use our own URL because it has to be a net object kind of URL, I guess, for a file. And there's a stream, and then we sort of, here is the actual call to compute hash, which will actually do the work. And then there's some kind of conversion to string here on it. So just a short example. And I believe you will get these presentations afterwards if you need to see them and see the code and so on. All right, so very much more primitive thing you can do is async CMD, which is calling a process like if you would type it in a shell. So you can just do any command. You can open the Internet Explorer, or you can list a directory or whatever. Now, this is of course very primitive. You don't have any real communication. You can just launch something, and you can expect some kind of results. A process will give you back the result if it worked or not. If you do it synchronously, you get that. If you do it asynchronously, you don't really get that result until it's done. So, but the good thing about it is that you have zero risk of memory contamination, because this will be a sort of fire and forget. You'll start the process, and it will be temporary, and it will die. So even if it leaks like hell, I mean, who cares? That memory will be cleaned up by the system later, so it's no problem. You can even, if you're building this Excel file that you're calling yourself, you can pretty much ignore all memory management in it because you know that it's a temporary file, so you can just ignore it. This example here is actually not asynchronous, and you should probably, if you're calling commands, you should do it asynchronously, so you don't, stop the whole CT process while you're doing it or waiting for the result. But I'd like to show this anyway because this is very useful. So this pipe CMD2 will do this command and pipe it to this string buffer, so you can actually print out the result immediately, which is very good when you are sort of getting there before it's working, so as you get the output and everything. And for instance, this didn't work on my computer with only doing dir, so I had to do like cmd/c dir, because otherwise it ended up in some Unix version of dir and it didn't work the way I wanted to do anyway. So that's, and that would be pretty invisible if you just do async cmd. You'll not see any output or anything. So it's a good trick to know. This is a more real example which is actually asynchronous and also implemented with a task, so you could actually use this within CET Designer running. So this one will list a directory on the web for this Emacs version here, and we'll call an executable that's called web directory.exe, which is a part of the CET install. And it will basically do a HTTP request and get the results and put it in a file, which is the second argument, the targets. So we do this, we call the async cmd, and if it works, we'll set up an idle task, and then we're done. And the idle task will get this target URL as its arg, so that will be the URL here, and we just wait here until the file is readable. And that works because the web directory is implemented that way, so it doesn't, begin to stream bytes to the target file a little bit at a time. It gets all the bytes, and then it sort of writes the file as a single operation. So this is, pretty important to know how the executable behaves. If you're going to just look for the file and see if it exists, you will want to know that it exists in its final shape. But this does. So when it's readable, we can read the text from it and print it out. So, and maybe I can actually have like a live example. I have the code here, so I think we can run it. And you see we got to the check here a few times, like check, and then answer is ready, and we got a text out from there, and if you'd like to, we can print the actual, print the text too, get something like this, in this case, which is just a web page, really. So that's an asynchronous call. I'll get back to this. All right, the next protocol is 0MQ. This is a little bit more advanced, or a lot more advanced, I would say, than asynchronous command, but you can do the same thing. You can launch an exe file, and then you set up a communication to it, which is two-way. So you can send messages to it and get replies, and the executable can also call into your code, I believe. It's really fast. You can transfer a lot of bytes through 0MQ, I believe. It's really effective in that way, and you can also make a lot of requests effectively. This is used for the catalog downloader, which is used, on every end-user machine, where the products are being downloaded on the fly. And I think we have a pretty advanced implementation of it for the catalog system. But it is pretty much work, I would say, to set it up correctly. And I haven't worked with it myself, so I can't tell you exactly how much, but there's definitely some work there. But you know, for like a more critical system in your extension, that might be good to have the speed and have all the features you need from this, instead of like the async CMD, which is really primitive. So we'll go a little bit into remote calls as well, and I think that the most common thing would be web service integration, like calling a web service and getting the results. There are many different ways to do this. We have some support. We have the it's actually misspelled, XML RPC, it's supposed to be, which is one way of doing it. SOAP is another way of interacting. It's also XML based, and REST is too, I believe. These communications normally use HTTP to communicate, which is really good because firewalls at the end user companies are probably open to port 80, which is the HTTP port, so that communication will pass through. And that's why so many protocols go that way, I guess. We are using XML RPC for our communication with the license server, with my configurer. All that kind of communication is going through that. I'm not sure if we have any actual SOAP or REST implementations. That will probably be in some customization in that case.
Do you mean SOAP or REST implementation within CM?
Yeah. Do you know of any?
We have one in C#.
Okay.
Yeah, but then we just call it.
Yeah, okay. Yeah. So that's one way of doing it. Yeah, I believe .NET has a good support for it. So yeah, that's probably a good idea. Yeah, this is just showing a little bit about how the XML RPC can look. So this is a class where we get the profile picture for a little my configurer icon in CET. So it's some kind of web service request, and what it needs is like this is the user ID, I believe, and we declare a method name. So this is the method or the procedure on the server that we want to call. And this is an argument that we are sending, the user ID. So for this user ID, we want to get the profile image. And this will build something like this. This XML here will be sent to the server. So you get the profile picture, and you have this user ID, and it's a string, 1, 2, 3 there. Maybe not the correct one, but will probably be your, never mind. So a couple of things to notice is that it is typed, for instance. So it's the first argument to the function, or if you just ignore this SSID. So this is a string, and if you pass something else than a string here, you can get an error response from the server saying that there's a type error. I expected a string, I got an int, for instance. Those kinds of feature. Of course, this is all in runtime. You can't get a compile error for this because it's it's not a compile thing. But it's anyway, it's pretty high level. So error management is pretty thought through and so on. You can do well. You have to manage it yourself, of course, but at least you get the error messages. So we have a thing called Cloud Sync, which is handling part of our Amazon integration. You know, you can, in your extension, you can put extension files on Amazon for your users to share in between them or upload, let's say, upload stats from your extension or something like that. And this is managed through these 3 layers. So we use my configurator to sort of keep track of what files we have uploaded to Amazon and to access them and to get the, what do you call that? There's some kind of security token or something like that you need to have access to that certain part of Amazon that we pay for somehow. So that is also an integration you can use. We're using this for uploading, publishing of catalogs. So it's and for some other things too, I believe. So on this MySQL SQLite, well, it's also an integration. I think of it more as a server-side integration. Usually on the server, you have a database where you store all your stuff, and you need to access it somehow. Of course, you can have a local database running on the end-user machine as well. I'm not sure when you would have that, but it's fully possible. You can also have access databases over the internet, I believe, through these interfaces. So, but I mean, modifying a database is sort of, I mean, getting data from a database would of course be an integration that is fully working, but sort of uploading or putting data, writing data to a database in itself is, well, meaningful, I guess, but you don't get anything to happen unless there is some interface and something else monitoring the database and looking for changes and displaying them somehow. So, but if you're just uploading stats or something like that, you can just fill up the database and someone will analyze the stats later or something like that. And then there are some other sort of older protocols that I thought I should mention as well. Which HTTP, you can do pretty advanced stuff. Actually, you can modify a server if the server looks at your web requests or the GET requests. Even a GET operation can actually change the server state on your web server. It's not meant to be that way. You're meant to use the post command or call if you want to change the state, but you know, people don't care too much about that. However, if you're going to like upload a large file, you'll need to use the post because GET has some kind of request limit. FTP is also available. We have support for it in the same language, but it's an old protocol, and the ports, FTP ports, are usually blocked by firewalls and so on. So I would not recommend it. We have used it in some extensions, but yeah, I think it's being phased out. And then there's the BITS protocol, which is Background Intelligent Transfer Service. It's Microsoft's sort of what drives the Windows updates. It's been around for a long time, since 2001, and it's open for use for other applications too. So, and we are using it still for the end-user bug reports to send them into some server for us. The good thing about it is that it is in itself throttled not to disturb the end-user computer. So if the user is streaming video or something like that, using a lot of bandwidth, BITS will not use any bandwidth. It will only use the bandwidth that is actually free at the moment. So that's pretty good. But otherwise, I would say it's a little bit a little bit unreliable. So I wouldn't suggesting using it for like a new implementation of yours. I have made some comparisons of these different protocols. So if we look at speed, what you can do with it versus complexity, I'll put DLL and CMQ right up there because they're very fast. You can do very effective stuff with them, but they are also more complex. And I think maybe CMQ is more complex than DLL, but I'm not sure. It depends on your DLL, I guess. Of course, I think CMD, for instance, that can be pretty fast depending on what you're doing. If you're going to launch 2,000 processes, I don't think it's very good because process starting is in itself a little bit slow on Windows. But if you're going to launch one process that is going to perform a heavy task, like, for instance, making a rendering or something, that can be very, the process in itself, of course, can be very fast. So it can have a good speed. And interop, I believe it's pretty slow. You shouldn't put it in your inner loops, perhaps, but you can use it. It's not a catastrophe in performance. And then I thought I made this with capability versus risk. So what you can do and what are the risks. So, and I think, like with the CMD, you can't do too much with it because it's so primitive in its form. But the risk is very low, so it might still be something to consider for a small task. And the DLL, of course, you can do a lot with it, but it's also a high risk. So James will manage that risks. And I think I've already said this now, but when to use what? I think CMD interop for quick solutions, smaller features that you want to throw in there. You don't have too much time to develop them or something. But if you have like system critical features that is really important for your customization, I would suggest spending some time in a more serious protocol so you can have better error management and for instance, do progress bars or something like that if you have a download or have more features. So I think I'm on time. If you want to ask something, you can do it now, or you can do it later after James has done his thing. So. Yep.
For the HTTP access, do you support HTTPS?
Yes, I think so. Yep.
Okay. And what about the verbs? Do you support get and post, but you also support cut, catch, or delete?
I'm not sure. Actually, so no, I'll have to try. We'll get back to you on that one. Yeah. Anything else right now? I'll give you this. You need to plug in your computer.
All right. Thank you, Stefan. As you said, I am James Redden. I'm with Knoll, here to talk to you about integrating C++ specifically into CM. So why am I here? What do I do? My background is in C++. I've done a lot of video games, done some vehicle work, and I've integrated several languages into other languages. mostly into C++, so it's kind of nice going the opposite. I've had experience with Lua, Python, and ActionScript, integrating those into C++. So I'm always searching for the best tool, and as good of a programming language as CM is, it's not always the best tool for the job. CET, they know that. That's why they have given us so many ways to integrate, whether it's DLL, ZMQ. So to start, why would you choose C++ over any of these other methods? You know, as he pointed out, it's high risk, very high risk. You could ruin CET experience for every user out there that uses your extension. So first you need to ask yourself, can it be done in CM feasibly? For our specific use case, that was a very easy no. One of the things that we needed was regular expressions. We could have got that from .NET, but it was a bit heavier lift than that, so started thinking about the C++ world. You know, again, is it more simple than just data retrieval? Are you just querying SQL, getting your data, sending it back? You can do that right in CM. There's no reason to go external for that. And then another thing is, it doesn't need code sharing. So if you're using this DLL in multiple tools, like with Knoll, we have several developer tools that we write custom for our data developers to help with their tasks, with their job. So we needed an extendable solution. And knowing C++ as I do, figured might as well go down this route, explore the options, and you know, C++ is truly extendable because once you have your API, once you have your interface, you can change that backend at any time. If you were using a local data store, just a CSV file, but your data grows and you need to access some MySQL, well, you can integrate MySQL into the C++ and access your data that way, and you haven't changed your API touching CM. So we'll go over some integration basics, and the first thing we'll look at is the import syntax. And if you're familiar with C++ DLLs, you know that you have to use the decal spec. You have to have a import and an export. So the way that CM handles this is with the import syntax. So a nice little thing that they added is, oh, no, we'll start over. Not a PowerPoint guy. Okay, back here. So we'll try this again. Technical difficulties. There we go. All right. So as you see here, path to DLL. So by default, if you just give it the name of your DLL, it's going to look for it inside of home bin folder, which there's a lot of issues with that. You're going to have to do some kind of a copy to get it there. So you can actually do the path to the DLL, and now you ship it with your extension. You don't have to run any kind of command to copy it over or anything. And there's two types that they're not necessarily new, but you probably don't use them day to day. I know there's several configurants that didn't know that there was a CSTR inside of CM. So these are types that you're going to use when interfacing with a DLL. CSTR, that's just your simple C string. Not much to say there. Byte, it's a byte. These aren't exciting or new types. They are just something you're probably not used to working with on the day-to-day. So who gets into compiling a DLL? So You can use any Windows compiler. You can use Visual Studio, Qt. These are great ways to just start. You can install it and be compiling within minutes. I know CET developers are going to say, oh, what about Emacs? All you need is a compiler. You can integrate that into Emacs and run your entire workflow right from there. You do need to match your DLL version, bit version. And so if you're only shipping a 64-bit, you only have to worry about a 64-bit DLL, 32. Even though I said Visual Studio is the fastest way to get your DLL compiled, you cannot actually use Visual C++. So if you go that route, you need to find the command, I believe it's like -ZE, and that will tell Visual Studio not to compile with Visual C++, just using standard C++. Not many languages can handle C++ naming, so you need to wrap all of your API in extern C to give it a simpler C naming convention, and that will allow CET to call it. So you're starting with C++, and you want to go down that road. The first thing you need to think about is API, because you can't be changing the way that the developers are interfacing with your DLL very much. You need to plan that out and create a good API, as you really need to do for most programming. As Stefan also mentioned, one of the big risks is memory management. And this goes for internal, like inside of your DLL. If you're calling new, you need to call delete. If you pass a pointer to CM, they don't know what to do with it. So you need some sort of a function to delete that. And with the development cycle of C++, it changes a little bit because you need the C++ DLL there before you can even start. And I ran into a big issue with this, and I worked with Eric to come up with a solution. All right, well, I can't compile the CM code because it's relying on this DLL that isn't built. And sure, I can build it and just sit it there, but that's not very good for continuous development. If the DLL changes and someone wants that change, how do you do it? Currently, there's no way, but through the partnership that we have, they are putting in some build hooks into the CET Build Center. So you have some automated builds. Whenever those kick off, there's going to be a pre-build hook, and you can have it build your CET DLL for integration. And that'll work very nice because anytime there's changes, it's just there. So quickly ran through the basics, and let's look at some actual code, the stuff you guys like to see. So the first thing, we'll start in the CM world, right, with the import syntax that I was talking about earlier. And as you can see, it's regular CM code. You got your package up here, stating what package it is, and every function that you want to have in your API, you need to define how it's called in CM. And so this is one of the nice things I like about C++ over like a .NET. Even though .NET gives you a lot for free, I'm not a big fan of the interop syntax. It's cumbersome, and with this, it's indistinguishable whether it's C++ code that you're running or CET code. And in fact, most CET code is C++ code behind the scenes. So here we just, you have to know what your DLL is beforehand. So you give it the function name, parameters, and then you tell it the symbol in C++. that you are touching. So then there's one thing that I have been figuring out as I go. There's Yep. So non-F glue. This is a bit of a syntax to tell CM not to bring in all of the debug data. And, bring in as little as possible. It's going to run faster this way, but you're going to lose out on your ability to debug the system within CM. And you can still rely on print statements like you do every day within CM. So that is the CM portion. Over here, we can look and see this is the DLL header. If you're familiar with C++, this looks pretty standard, right? You got some pound defines for make DLL, because if you're compiling it for export, you need it marked export. If you're importing it, obviously you need it marked for import. This portion, you don't need to really worry about this. I put it there because I'm used to doing it and it's just second nature. But that's actually, the importing is actually what is being done here in the CM with the import syntax. You can see I wrapped everything around with extern C to get the nice naming convention, and that's it. Nothing too complex yet. So now that we have a decent understanding of the basics and we've seen a little bit of code, I want to take a step back and talk about why we needed to use C++ in the first place. One of his examples was external data, for parts and pricing, and that really was our use case, right? We have CSV files and databases with different parts and pricing, and we need to look those up and kind of calculate them out because they're in formulas. And I'll go here to give you an idea of what a very basic formula looks like. This is our syntax for that I've defined for a variable with the brackets, just so I can easily denote what is a variable. So this is just going to look up that particular part, price, whatever that data is behind the scenes, multiply it by 3, and be done. So, go look a little bit more at the internals here that we're doing. So obviously you need a function to load the data, and then this is where I was talking. It's extensible. Right now, this is just a CSV file. As the data grows, we could easily throw that into an SQL database. And here we would keep the same API, just change the internals. None of the other developers are privy to the change. So we'll go down. One of the, as I said, the first thought I had for going down this road was, well, I need regular expressions. C++ has regular expressions. I mean, not the best, but they get the job done, and it's better than iterating over string and trying to parse it out that way. So, too far. This is the part that I really wanted to draw your attention to, is this new command right here. So this is where the danger increases. Because I'm not looking up, I'm looking up the data and I'm creating a new string based on all of that data. It will, if you just pass it the variable, it's going to fall out of scope, and as soon as it goes to CM, it's not going to be there. So if you have the memory in, if the data is in memory and it's not just in a local scope, you can just pass that data and you'll be fine. You don't really have to worry about new if you don't want to. You can design around it. You can limit the risks by doing that. In this case, I didn't want to load all of these up into memories. We're talking millions and millions of lines of formulas that we're parsing. So I create a new variable, or a new character array, and I return it. Nothing that fancy. And in CM, I get my string back. And this is where the integration, I think, works very well, because what I'm doing, I'm looking up the data, and I'm putting it into this string. So it's really just becoming a mathematical formula. Well, one of the limitations of C++, you can't evaluate a string and get a number. But CM does have that capability. So here's where I create the string, and by the time it's done with this algorithm, it's turning in from this to essentially something like just a simple calculation. That gets passed to CM, and I use the CM eval command to evaluate it and get a single number, and then I insert that into the catalog. And this greatly reduces the amount of work our catalog developers have to do, and they're able to speed through catalog development even better and faster. So let's see. I was already on it. All right. So earlier I was talking about debugging this within CM. There's not really a great way to do it. You can't look at the stack, you can't look at anything. So it's already a DLL. I just created a simple program here to run through, and I can test out a simple formula, or whatever formula I want. If a particular formula is crashing or not working, then we just insert it into here, run it. I get some better information. I actually get a stack dump, and I can see what was happening. Why did one particular formula break the system? And it's quite nice to do it this way, because you can, we're integrating this into CM. You should know before you do that integration that it is correct, that it is working. And you just have a little bit more debugging power. I mean, as I said, it's actually a stack. It's not completely print statements. So let me one more file that I don't have open. We will just do it here. So over here, I'm going to just kind of go over, how you would use this. It's not that exciting at this point. It's effectively CM code. But you would just come in here, load data, give it a list. As I said, we are loading up CSV files at the moment. We're just going to copy this attribute right here. And here we would eval the string. Right? I'm not going to show you that right now. That's outside of the scope. It's a great subject. Encourage you to look into the CM runtime and check out their the way that you can eval your own code. And you can, with that, you can even load any CM code and run it. But again, that's outside of the scope of this presentation. So with this is right here. This is actually touching the DLL. It's going to load the data. It's going to parse the formula. And here we can see it's returning a C string. And these are lightweight, but don't go using them instead of a regular string. You lose out on 90% of the functionality. It's just not worth it unless you're inside of the C++ world, as I am. So there's a problem with this. And as I showed you earlier over here, I'm calling new. So call to this parse formula behind the scenes is creating new memory. And I haven't done anything about it, which is why I have this lovely little kn delete formula function up here. It will, we can go over to C++ and look at it. Here we can see, simple one line. It's just deleting the pointer. That's it. Nothing exciting. It is just necessary. And as I said, this is not entirely necessary. You can minimize the risk of memory management. And I encourage you to do so if you go down this route, because no one's going to like it if they're using CET for a few hours, they're in big design session, then all of a sudden it just crashes and you lose all your work, no save data. That's going to annoy a few users. So we simply just come down here and we delete the formula. And that is it. We have effectively managed our memory. One other thing to add here is with a C string, that's what you're going to always return. You're not going to return a string, as far as I know. There is 1,000 questions I still have about this, as it's a very broad topic. But you can then just create a variable, and I'm doing bad CET practice because I've been in C++ too long. So you can, you can create a string from a C string, and vice versa. There's even here you can do new ret.cster, and just like any of the other type casting that goes on, this will work. So that's a great way to get your data into C++. In fact, I here would need to do that to get this to compile and behave properly. So, in not so much of a nutshell, that is integrating C++ into CM. Are there any questions? Yes.
Just one little thing. When you call kn delete formula, you have to use that original CSTR reference. You can't use new ret.
Oh no, you would not want to use new ret because what's happening here is, this is in the CM stack. This is going to create a new. It's going to create a new variable, and it's going to copy the contents of ret into new ret.
Okay.
So if ret falls out of scope before you are able to call it, so if I did something like this, now this C string ret is out of scope, and well, this wouldn't compile, and B, you lose your reference to the data.
It's probably worth noting that after you do the delete formula there, it might be a good idea to assign red to null. Because if you would, for instance, print it or anything after that, it will.
Oh, yes, yes.
Because it's still pointing to that pointer which has now been freed.
Yes, you are right, and that's pretty
But
standard.
that's probably at the end of your function anyway, so
Mhm.
the scope is probably ending there. You know, but
Exactly, and I couldn't show the actual implementation.
Write a function that returns a CM curve and then does all this.
Oh, yeah, definitely, and in our actual implementation, this is just kind of a stripped down version of what can I actually show from all of this private code. so yeah, that's a great point. Any other questions for me or Stefan? No? All right, well, thank you for your time.